A person knows how to talk at the age of 1 or 2, but he or she keeps learning how to talk, when to talk, and why to talk in whole life. Hello everyone, hello intellectuals, I am S.K. Thakur and you are watching this video in Digital Maths Academy. Today's topic is relation. In one sentence, we can define relation as: relation is defined as the subset of the Cartesian product A cross B, where A and B are two non-empty sets, and it's represented by R equals to x comma y. And here we write x belongs to A and y belongs to B. We are going to explain relation by so many examples, and of course you will understand very clearly. Let's say you have two sets A and B, then you can find the Cartesian product. Now you can see some order pairs in the Cartesian product: 1, 1, 1, 3, 1, 4, 2, 1. Likewise, we have altogether 9 order pairs. Now, if we see all the order pairs, then we see here somewhere x component is equal, x components are equal. Somewhere x component is less than y component. Sometimes x component is greater than y component. So if we select here the first relation, equal components, right, and the order pairs whose components are equal, then we can get 1, 1 and 4, 4, right? And symbolically we can write it as x comma y, right? That's representing the order pairs, and y equals to x means both the components are equal. Likewise, another relation we write here: 2, 1, 4, 1, 4, 3, and we see in all the order pairs the second component, that's the y component, is greater than the x component. Likewise, we can select all the order pairs such that the sum of the components is equal or less than 5. Yes, we can share 1 plus 1 is 2 and 2 is less than 5. Similarly, 1 plus 3 is 4 and 4 is less than 5. And 1 plus 4 equals to 5 and 5 is equal to 5. So under this relation, under this condition, we can select the order pairs, right? And I have selected some order pairs under the condition. The second is the square of the first. So you can see 1 is the square of 1, 4 is the square of 2. Likewise, so only 2 order pairs we can select under this condition. Likewise, only 2 orders pair we can select under the first condition. We can say that 9 is the square of 3, but we cannot select here 3, 9 because 3, 9 is not a part of the Cartesian product. So we can say that relation is the subset of the Cartesian product, right? So I have shown the 4 relations, so you can make so many relations from the Cartesian product, but be sure the order pairs must be from the Cartesian product only, right? We wrote here 1, 1, 4, 4, right? So here both the components are equal. So we can write here is equal to means what? X component is equal to the y component. So in shortcut or symbolically we write like this also. Similarly here, x component is less than the y component. Similarly here we can write now the sum of the components x plus y is less and equals to 5. So we can write is sum is less and equal to 5. Likewise here is square root we have to write now, because is means the x component, and we can see the x component is square root of y component, or we can say y component is square root of the x component. So we have to write x is square root of y, right? And after that, then let we have one relation, right? And the relation is 1, 1, 2, 4 and 3, 9, right? So when we collect the x component of the relation, then you can see 1, 2, 3, and that's called domain, right? Not to forget this line, okay? That's a domain. 1, 2, 3, that's a collection or the set of the x component of the relation. Similarly, the set of the y components of the relation is known as the range. So range we have 1, 4, 9, so we have. And How to find the inverse relation? Inverse relation is very easy, right? Interchanging the domain and the range. So 1, 2, 3, 1, 2, 3 become the range, and 1, 4, 9 become domain, right? So inverse relation we can represent is like that: 1, 1, 4, 2, and 9, 3. Representation of relation. By how many ways we can represent a relation? So we have here relation 1, 1, 2, 4, and 3, 9. So first of all, we write the relation as 1, 1, 2, 4, 3, 9, right? And this is the set of order pair. Set of order pair. All of you know that set means what? Set means the categorization of the elements along with comma, right, inside the curly brackets. So here R equals to curly brackets, we can write all the relations. So this is a set of order pairs. Set builder form or the rule method. Set builder form, the rule method means we have to write the relation between the components. Here the second one is the square of the first one, so we can write y equals x square, but not to forget here to write x and y, because x and y represents all the order pairs under the given condition. In the tabulation method, we are going to write the domain and the range in the table form. So table form depends on you, right? So we can write like this here. We can write first of all here A, then you can write here B, then we are writing here the domain 1, 2, and 3, that of the range 1, 4, and 9, and we make the table. So we are going to make the table like this. So here the upper one, that is A. A represents the set of the domain, and the B represents the set of the range. And the set of the range, we also say codomain, and the codomain and the range, what they mean, very soon I am going to explain about this in the chapter function. Now the next part is we have here arrow diagram method, right? So how to represent the given relation in the arrow diagram? So to represent in the arrow diagram, first of all we have to write here A, then here B, then all the domain here 1, 2, and 3, and that of all the range here also 1, 4, and 9, and we are going to enclose them in oval, right? And after that here A is related to 1, 2 is related to 4, and that of 3 is to 9, and it is relation, right? And we are going to show the relation by this arrow diagram, right? So here it is the relation. So this is the arrow diagram, right? So we can represent the relation by arrow diagram also. The next one is that graphic or lattice method. So in the graphic or lattice here we have 1, 1, 2, 4, and 3, 9. So they are as points, right? So we are going to find out the points where they lie, right? So we have graph, you can see. So we have to have graph, right? So here 1, 1. So 1, 1, you can see, of course it lies over this point. So I'm going to change the color so you can clearly hear. That is 1, 1. So and now next one is 2, 4. So that's 2, 4. It lies here. So 1, 1. Better to write the coordinates also. If you write the coordinates, that will be more clear. And 2, 4. So right here 2, 4. Likewise, you have 3, 9. So we have 3 and 9, 3, and there we can write here 9, right? So that is our 3, 9, right? So similarly that you saw the points in the graph, and such type of method is called graph or lattice method. So likewise, I have written all the methods of representing the order pairs in table. You can see set of order pair, set builder form, tabulation method, arrow diagram, or graphic or lattice method. So hope you may have understood this video, and the next part of the video will be some more examples of the relation and the codomain, range, pre-image, and very soon I am going to explain about the function, and function is very crucial in optional mathematics. It's the root of optional mathematics, we can say. So thank you. Not to forget to like, not to forget to share this video, and if you are new, not to forget to subscribe my channel, because it's your channel. Have a great day ahead.